Space wants you.
We're going back to the moon and then to Mars.
Want to go to space? Let's go.
Just getting to space is the easiest part.
Draw it, write it, build it, dream it, innovate it, invent
Because
it.
once you get to space, you actually have to live in it. Space wants you dead.
Let's expand our thinking.
It's time to think outside of the box.
Let's go.
I see stars.
Hello and welcome to the Cities in Space podcast. We're here to help you discover your future in space. I'm so happy to have you here joining us today. I'm your host, Holly Malier. Part of our mission at STEAMSPACE and at Cities in Space is to reach every student everywhere and get them excited about space and their future and what opportunities lie ahead of them. This is why I am extra thrilled to be introducing you to today's guest. He has had quite a career in the space industry, and I'm so excited for you to learn about him. I had the opportunity to meet our guest many years ago at the New Worlds Conference in Austin, Texas. He worked with our students during our Cities in Space Leadership Summit, and the kids were blown away with his experience, intellect, and genuine kindness. Dr. Phil Metzger is director of the Stephen W. Hawking Center for Microgravity Research and Education, where they are developing research, technology, and educational programs focused on reduced gravity environments, including the moon, Mars, asteroids, and other zero-gravity spaces. In addition to that, Dr. Metzger is a research professor and planetary scientist at the University of Central Florida. In that role, he works on developing technology for space mining. Yes, I said that. Space mining, resource extraction on the moon, Mars, and other small prospecting spacecraft. He lectures on planetary engineering and economic planetary science, which are newly developing fields that combine planetary and space science, engineering, and economics. In addition to this, Dr. Metzger works with the United Launch Alliance, or ULA for short, and SpaceX, focusing on lunar water mining camps and humans to Mars missions. Dr. Metzger was also the co-founder of NASA Kennedy Space Center SwampWorks, which is extremely cool. Audience, if you don't know about this one, look it up. SwampWorks was created to accelerate innovation for NASA to benefit space exploration and everyone living on Earth. Researchers and scientists take ideas from concept through development and into application to support NASA's missions, including working and living on the surface of the moon and eventually on other bodies in our solar system. I think it's pretty easy to understand how his work at SwampWorks ties into the work he's doing today. But Dr. Metzger doesn't just study space. In the 1980s and 90s, he worked on the Space Shuttle's vehicle processing team for avionics systems and ground support. Then from 1992 to 2002, he worked to support the International Space Station. After all I've shared thus far, it probably won't surprise you that he has received numerous awards such as the Silver Snoopy Award for his outstanding performance, contributing to flight safety and the STS-124 shuttle mission success. Students, fewer than 1% of aerospace program workforce receive this award. This makes it an incredibly big deal. He was recognized for NASA's Scientist Engineer of the Year in 2011, and then in 2014, he received the American Society of Civil Engineers Aerospace Division Executive Committee's Outstanding Technical Contribution Award. This recognizes people who have made significant contributions to the advancement of aerospace engineering, sciences, technology, as well as space exploration and construction. Okay, I'm going to stop there, but audience, truthfully, I could talk the entire podcast about Dr. Metzger's accomplishments towards the development and exploration of space. But without any further ado, visiting us from Florida. Welcome, Phil. Welcome.
Hi, Holly. Great to see you.
It's great to see you. Thanks for being here today. How are you?
Doing well, doing well.
Well, I'm glad, and we're all glad you're here. So, there are so many topics I'd love to discuss with you today, including ice deposits on the moon, your work on dust, Martian and lunar soil, and how it's going to be interacting with landing pads, infrastructure, rocket exhaust, and then, of course, your work with robots. But given that we only have 30 minutes, I want to first drill down on your keen interest in the democratization of space, and in particular, access. Does that sound good?
Sure. That's
All
actually
right.
just excited about.
Yay, me too. So, okay, jump in and correct me if I am wrong. But when I think about democratization of space, I think about making space more accessible and inclusive for a wider range of people and organizations. Yet, as you know, a $1 trillion commercial space industry is emerging. And I believe there are 90 countries now that have space agencies or corporations. And yet, when I talk to a young person, in the Gen Z range in particular, many still feel limited in their opportunities and choice for entering the industry. We want to reach the underrepresented youth globally. So, what is happening in the space industry that could be changing this perception of accessibility? And what are some opportunities that young people should be looking at in order to participate in this golden age of space?
Mhm. Well, the reason I got so excited or so interested in democratizing space is because I started to realize that after we develop the ability to extract resources and do manufacturing in space, and we start to diversify that supply chain off the planet, eventually that supply chain is going to start growing, and we have basically no limit to resources or energy, and the labor will be robotic. And so it's going to be able to grow to gargantuan levels of productivity, to the point that whoever owns that industry could basically rule the whole solar system. And
Oh,
I actually a threat to democracy unless we can find a way to make sure that we all own that industry in space.
yeah.
But it's difficult because you can't just sell your house and buy a ticket to the moon and build a log cabin out of the forest of trees on the moon, which don't exist,
Mhm.
and hunt for turkeys and live on the moon. It takes rockets and spaceships and a huge amount of capital, so that the bar of entry is so high and most people cannot participate.
Right.
And so we're at the Stephen Hawking Center. We're specifically interested in trying to develop ways for people to participate, to become participants in space, creating on ramps, creating opportunities. So it's education, hands on work, developing entrepreneurship, and developing technologies, intellectual property. And reaching out to the whole globe so that we can have so that we can all go to space together.
I love that. I love that so much. And yeah, I think it's interesting how you talked about, though traveling to the moon and Mars and other places in our solar system, in some ways, one could compare it to the Wild West and the expansion. However, we do not know of indigenous aliens living there at this moment in time. And also, there's not a log cabin you can build from resources. We are going to have to rely on so many of these technologies and be so dependent on rockets. So I love there's so many paths emerging in this, and I hope all these things do continue to grow and happen and more opportunities appear like you're doing at the Stephen W. Hawking Center, because that's going to be really, really important. We're going to need everybody, as you know, to really make this venture grow successfully without just a small few owning the rights to everything.
So that's such an important point, because right now the big thing in artificial intelligence is scaling up. They've learned that just by making the AI bigger, it gets smarter and smarter. Well, the same thing is true about humanity. The more human minds we include in what we're doing in space, the smarter and smarter we get as a community. So we really, not only is it important for the individuals to be able to participate, but it's important for the overall effort if we can get more people to participate. I think by including humans from all over the globe in space, we're going to make it happen faster and better. So you asked,
Yeah, agreed.
yeah, what are some of the things we're doing to make that happen? Well, we're working on educational programs that are competitions where the students are developing robotics. And we've already shown that we know how to learn from the competitions to make better robots. So it's not just a game, but it's actually a technology development program built around the game. So we can make it fun and entertaining, self-sustaining, and also make better robots, so that we can create methods for people to be participants in space.
That's great. I love that. And any way you can incorporate not only competition, but collaboration, and then just keep scaling up that knowledge. That's one thing we've seen at Cities in Space through the years. We have 500 kids on site competing, which you've seen. And
Mhm.
over a decade, we've just watched the the product, I guess, for lack of a better word, just intensify and grow because in the meantime, these kids are working together, they're collaborating, they're brainstorming together, teams from different schools, and you just see this blossoming of intellect. And that's what we need. And I love it that you're already observing that with your robotics. This is fantastic. So,
The reason we got this idea of crowdsourcing through the competitions was from the NASA competition. We've evaluated 500 robots over the years, and we've kept data, and we've been able to learn things about how to build lunar robots that you would not have gotten any other way other than by having 500 robots. And
wow.
there's no way NASA could have afforded to build 500 prototypes, but by having the competitions, they're delivered to us for free by these excited, enthusiastic students. So it's a really cool win-win opportunity.
That is a win-win. And think of all the lives you're changing for these students working with them, right? You could be path changing for all of them. So, or definitely a lot of them. So, switching gears and still thinking on the theme, I'd like to talk a little bit about mining on the moon and economic planetary science. Okay, you touched on this just for a minute a few minutes ago. Next month, I'm going to be interviewing Michelle Hanlon with For All Moonkind. And I know that you're involved with that amazing future thinking organization, which I adore. Two things that I've heard Michelle discuss, and I found consistent with some of the ideas in your articles and tweets, which I want to talk about, are taking business and manufacturing off planet, like you were discussing, to let our Earth recover a bit and have more environmental benefit while we do the heavy lifting out there. I've also heard a lot of discussion about heritage and preserving heritage sites on the moon. I'm bringing this up again because I think this is an idea that's incorporated into the democratization and access. And I'd love it if you just talked a little further about this and including that heritage piece.
Yeah, so a few years, well, it's been quite a few years ago now, I was contacted by a space company who wanted to know what is the best way to land a rocket near the Apollo sites that are on the moon.
Mm.
They knew that I was working on the physics of how rocket exhaust blows soil, so they wanted me to give them some advice. And I talked to our management in NASA, and they told me, absolutely, you cannot give them any advice because we don't own the moon. You know, the jurisdiction is under the United Nations, and so we cannot talk to them. And I was freaking out, worried that, oh no, they're going to go land near the Apollo sites and sandblast and ruin everything.
Right?
So we finally proposed to NASA, why don't we just write a document that is a guidelines that are voluntary, so that at least we're communicating to the world the best practices. and they agreed to it. So we went through an effort. NASA headquarters put together a team, and I was a part of a team. And so we worked on these guidelines for how to land on the Apollo sites. Well, when they put the team together, they brought in anthropologists and historians and archaeologists.
Nice.
And the archaeologists said something that blew my mind. It was an archaeologist from New Mexico State, and she said the Apollo sites on the moon are arguably the most important archaeological site in the entire human sphere because it's the first place where humans stepped onto another world.
Mhm.
And my mind went, wow, I just thought we were going to be protecting some metal, but no, it's like that level of importance in the history and the just the sweeping importance of that mission. So yeah, we put together some guidelines. The guidelines need to be updated. We've made a lot of progress in understanding the physics of how rocket exhaust blows soil, but there's still a lot we don't know about it. And Michelle came along and took up the torch, Michelle Hanlon, and she's now got permanent observer status at the United Nations for her organization,
Yeah.
and has been working with the UN to try to address preserving those sites. And she's become very interested in the rocket exhaust problems.
Yeah. And you've been, I'd like to say, very interested in dust and soil for quite a while as well. I know you've done a lot of research with earlier missions, including Viking. And, we both know Rachel Tillman, who runs Viking Mars Preservation. She's all about heritage as well. And so I know that dust and also preserving these sites is probably a really big part of your research, whether it's on the side. Would that be on the side research, or are you incorporating that kind of research into your current position?
Well, I'm doing research for NASA on a number of grants
Hmm.
in addition to directing the Hawking Center. So it is part of my mainline research still. I've been doing this for, I guess, close to 25 years working on this problem.
Yeah.
But yeah, the Apollo 12 mission brought back pieces from the Surveyor 3 spacecraft that had sat on the moon for for 2.5 years. The Apollo lander landed near the Surveyor and sandblasted it. So they went
Oh my
over, cut pieces off, and brought them back to Earth. And I had those in a safe in my lab for a few years, studying the amount of sandblasting that happened. And it was really extreme sandblasting. So that's why we're worried about going to visit the Apollo sites, the other heritage sites on the moon. If you land too close, you could do some extreme damage. We're also worried about it for international cooperation because
yeah.
if somebody puts an outpost on the moon, then they might say we need you to not land any closer than 50 kilometers. And so you might start carving up the moon with de facto territory
Right.
and a way to get around the Outer Space Treaty. So we're trying to make sure that that doesn't happen. We're trying to figure out how to manage the rocket blast effects without carving up the moon into territory.
So many implications. I mean,
Mm.
and in my head, I'm thinking about all the jobs and careers that this will create for people for protecting these territories or defending, making it, equitable for all. So there's so many implications with this,
Oh, and
right?
let me tell you something that I think is so exciting. This particular problem is a good example of what I want to say. The problem with trying to solve the physics of rocket exhaust blowing lunar soil is that the rocket exhaust is spreading out into vacuum and it behaves differently than regular gas as it goes into vacuum. We can't do those experiments here on the Earth because
Mm.
we don't have a vacuum chamber big enough. And so you can only do the research on the moon. I think one day, not too far in the future, we will have a research station on the moon studying the physics of gas expanding into vacuum and blowing dust and a lot of other types of physics. So I really think we're going to have university habitats on the moon where we're sending researchers, postdocs, and grad students to actually live for a while on the moon doing research. I think we're within just a few decades of that being real.
I'll go. I could do it. I mean, I'll be about 80 by then, but sure, I can do it. I mean, you, Dr. Metzger, are quite notorious with your tweets. I'm sure you're aware of this. I mean, we're already talking about all these things. I've noticed you are very much about access and science for all, whether you're talking about dust or robots or other forms of science. I mean, this is one of your passions is sharing all this knowledge with everybody. And this is something I love about this topic, access and democratization. Are you able to like really like funnel your research into these tweets? Like you figure out a new thing and you're like, oh my gosh, everyone, let me share
Yeah,
this
really,
because
I
they go
love.
long, they go detailed, Phil.
Yeah, I've done tweet threads that are probably up to 100 tweets in a row
Oh
sometimes.
my God.
Yeah, the most recent one was I was sitting in McDonald's working on the physics of rock blowing soil.
As you do, as you do, you know.
I was like, whoa, I think I just figured it out. And I was so excited. I went on Twitter, sitting there in McDonald's, and started tweeting about it. I can't tell you everything right now, but I can tell you some of it. And so, yeah, I love going on Twitter and talking about science.
Oh my God. McDonald's, would you like to be a sponsor for this season? Just reach out. Reach out. Okay. Well, as promised, thank you for all that. I have a couple of student questions. I definitely want to be able to get in on this podcast. Are you ready for these? Are you ready? Okay. Here we go. From Sydney, who is a freshman in college. I've started school for aerospace engineering, but I really want my focus to be asteroid mining and mining on the moon. What are some directions I should take for this that is the correct trajectory that I want to have? That's a really good question.
That's a hard question. In general, what I tell students to do is, first of all, get involved in hands-on activities, join a robotics club or a rocketry club, because the hands-on of learning how to build stuff is crucial. And also the camaraderie, having a group of people
Yeah.
working is really encouraging, and it'll help keep your energy level. But the second thing I tell students is networking. Try to get involved in a club like the Students for the Exploration and Development of Space, or some other clubs like that. Try to go to some conferences maybe, and meet people. Don't be afraid to walk up to people and ask to shake their hand and introduce yourself, and just talk to them. I have students come up to me all the time and talk to me like that. And as a researcher, I get energized by that. I love talking with students. It's the best part of the job because you see the optimism and the energy, and it gives me the energy to keep going. So networking, hands-on. Also, internships are really vital.
Yeah.
Try as hard as you can to get an internship. Now, my daughter one time wanted a physics internship, but she waited too late to apply. And I told her, you're not going to get one at this point because they're already filled up. But I said, if you really want one, I recommend that you volunteer to work for free for the summer, and somebody will take you, and you will get the experience, and then you'll have a foot in the door.
Yeah.
And so he said, yeah, send my name out. So I emailed a whole lot of people, and 2 people offered to take her. And she ended up getting hired by this lab when she was still a high school student. She was working in a college physics lab for her last 1 or 2 years of high school. And she ended up getting a degree in physics, and she's now in graduate school in physics. So whatever you have to do, by hook or by crook, try to get an internship where you can get some real organization experience to see what it's like in the real world.
That's great
So
advice. Yeah.
those are some basics
Mhm.
that I recommend everybody do. If you want to get into space mining in particular, it wouldn't hurt to take some planetary science or astronomy classes. I think aerospace engineering is a fantastic field for that degree program for space mining. I work with a lot of aero engineers. I'm a physicist, planetary scientist, but I love working in groups that are like 1/3 scientists, 2/3 engineers, because the mix of skills is really good. So it's a good degree program as is, but if you can get any geology, that could help.
Yeah.
Uh, Also, getting some economics training would be helpful too, because ultimately mining is about economics. You're not going to mine something that makes you poorer for doing it.
That's a
So that
really good point. Yeah. That's true. And, there are so many groups like SEDS and so many conferences all over the world that are always looking for younger volunteers to help out with whether it's, setting out name cards or just helping organize younger students. There's always a need for that. And it's interesting, many years ago, I think I was a freshman in college. I was working full time and going to college, but I really wanted to learn a new skill, and no one would hire me because I really knew nothing about it. I knew like the basics. And so I did say, can I just work 2 days for free? And lo and behold, I learned and I ended up getting a job and it was amazing. But it can be really hard when you're very busy in school and work. But there are sometimes those little windows you can slip into and they will serve you well. So, really good advice. I have another question from Cynthia. She's a sophomore in high school. I saw that you were discussing democratization of space for this podcast today. I'm interested in studying mental health and psychology and would love to be one of those individuals who help citizens adapt when living in small habitats on the moon or Mars or even in space like the ISS. Do you think that is going to be a needed profession in the coming decades in the industry? This is so interesting. We've had several questions about mental health and psychology this past few podcasts. Anyway,
Well, I can't promise how soon there's going to be a lot of people living in space. We just don't know yet.
yeah.
But yeah, clearly there's going to be a need for people who are experts in this, because wherever people go, we take our humanity with us, including all of our problems, our
Mhm.
struggles, part of who we are. And when you put people together in a small, closed environment, it can cause those problems to come out even more. Um, but another aspect of this is I strongly believe that as we go into space, we need to all go together as a community. And that means all professions need to be going into space.
Mhm.
Art, music, literature, history, sociology, as well as the sciences, the hard sciences, and physics and the math. Because I like this example. When the first humans came into the American continents across the Bering land bridge, about 10 or 20,000 years ago. They came as a community, the whole community came together. And so that's what we need to be doing in space.
Hmm.
As we go, we need to find ways to open it up for the whole community to go. Now, in addition to mental health workers going to space as problem solvers, I think there's going to be room for research in space. We're going to need people who
Yeah.
study psychology and to study uh, mental illnesses and counseling for people in space, just to understand how we as humans tick. The space environment is often used as a laboratory to study physics. We'll go up in microgravity and we'll study fluid flow, not because we necessarily want to do fluid flow right now in microgravity, but because the microgravity opens up the opportunity to study it in a new way.
Yeah.
And so as we put humans in space, we're going to be stressing ourselves, facing new challenges. And I think that's going to be a fantastic opportunity to study who we are as human beings. So maybe that's another way to look at it.
That's a great answer. Cynthia, that was a great question. We're big, our team is very big believer of STEAM. We believe in the arts and the soft skills in addition to all of the aerospace and the engineering and tech and everything. We believe everyone is needed for exactly that reason as a community to make everything better and work better together, right? So, excellent. Well, this has been a fantastic show, but I always have to ask the question, what am I forgetting to ask you? What did I not ask? And what do you want to tell our young audience? I try to think of it all. but I don't think of it all. So help me out here.
I think you covered a lot of good things. I guess maybe one topic is moon, Mars, or asteroids. Some people argue we should be going to Mars. Some argue we should be going to the moon.
Yeah.
I think all of the above is the right answer, but really, I'm more of a moon and cislunar space person.
Hmm.
I think we should be building industry off of the planet in order to support and benefit the planet. And I think with artificial intelligence exploding over the next decade, I really believe it's going to be important that we start putting the computers in space off of planet Earth. So it's not competing with the ecosystems for land and for energy. And I believe we can do it. There are already companies looking at how to do it. But I think it's going to be really vital for the environment of planet Earth to develop industry in space. So if people want to go settle on Mars, they're going to need to buy rocket fuel. And so people working on the moon making rocket fuel will be supported by them. So I think it's all synergistic.
Right.
Or I
Yeah.
think it's all of the above. But basically, I'm a cislunar space person.
Makes sense though, right? And with Artemis and the programs we're working on, the moon is definitely a little more accessible at this point in time for Earth and for the outer reaches of space. So this makes sense in setting up an economy, which is what you study as well, to work with Mars, the moon, and Earth, as well as ISS and other stations in free space. It makes sense. This has been grand. I really appreciate you being here, Phil. And we will all be following your work at Stephen Hawking Center for Microgravity to see what other endeavors you are going to be taking on. Teachers, students, look for the center's link in our announcement. Thank you so much, Phil. It has been grand. We will be following your work and the Hawking Center for Microgravity to see what other endeavors you take on. Teachers, students, look for the center's link in our announcement. Audience, if you like what you heard and learned about today, please follow us on our Cities in Space Facebook page, as well as our Instagram at Steaming for Space. Share this podcast with your friends, your colleagues, the world. We can be found on most major podcast platforms such as Spotify, Apple, Google, and Amazon. As you know, we love to hear from you. If you would like the opportunity to have your class submit questions for our future guests, please reach out and we will add you to our email list. You can do this by going to our website at steam-space.org and hitting the Contact Us button. We are so grateful for our supporters, and if you would like to join others with a donation as we seek to reach students everywhere, please visit our site and hit Support Us. Every donation matters and helps us to provide new content and create aligned essential questions and classroom projects, which you can also find on our website along with our podcast for free. Special thanks to our producers at RNCN Studios, our podcast musician Nate Sivan, and thank you to our wonderful team at STEAMSPACE. It takes a village, my friends. That's a wrap, audience. Our next guest will be Michelle Hanlon. She is a space lawyer as well as co-founder of For All Moonkind. You are going to want to hear about this one. We can't wait to be with you next time. In the meantime, I'm Holly Malier. Keep looking up.